All right, so geometry, day 2 of probability and statistics. We're going to talk about conditional probability. Again, when you think of conditional probability, think of you have a condition that is met. Now you must find a probability. All right. So conditional probability is the probability that one event happens given that another event is known to have happened. Some condition is already met. That is the given idea. Okay. So when you're looking for conditional probability that B happens given A, B happens given A already has happened, it's this type of notation. This bar means given. So B given A. Now there are formulas right here that I need you to try to remember, okay? So first, when you're trying to find the probability of B given A, the denominator is the probability of A. That's where you put what has already happened. Okay, typically the bottom is the total, the grand total, but you don't need that. You don't need the grand total anymore. Okay, so that's what I like to think of when I think of conditional probability. I like to think of how it limits your total, limits the total. So, for instance, if we're looking at our class is made up of boys and girls, males and females. So instead of having the bottom number in my probability being my total class enrollment, maybe I know that it's only the girls I'm looking at. So then the bottom number would only be the number of girls, not the total number of students. Okay, so again, it limits the total. The top is then the intersection of the events, A and B. All right. Again, here's your and notation. And again, this is another non-numerical way. This is more of a layman's term way. It's the probability of both or the probability of the given. Okay. So this is conditional probability. So let's jump right into a couple of problems. I'm going to do 4 problems for you, or with you, I should say, with you. Okay, so the first problem here says, in a class of students, the following data table summarizes how many students play an instrument or a sport. What is the probability that a student who plays a sport does not play an instrument? So when you see this word who, that means given. So we are trying to find the probability that that someone who plays a sport does not play an instrument. So we're trying to find the probability of not playing an instrument given that they do play a sport. So probably of not an instrument given that they play a sport. Okay, so again, it's going to be the probability of both over the probability that they play a sport. That's what we're going to do. Okay, so let's look at our table here. Now, first of all, I love to fill in the total. So add a total column, a total row. Again, add 19, 5, add left to right, 12, and 12. Add down, add left to right, that's 24. So remember, in conditional probability, we're never going to use that 24. So we know that this person plays a sport. So we are only looking at this row right here, who play a sport. This total is your bottom number, 12. And out of those 12, we want to know how many do not play an instrument. Find in this row the number that do not play an instrument, and that is 3. So it's not over 24, it's only out of 12. And again, we simplify, divide by 3, that's 1/4. And that should be the answer. There we go. Okay, let's do another problem. Here we go. So this one says, in a class of students, the following data table summarizes how many students have a cat or dog. What is the probability that a student has a cat given that they do not have a dog, right? So here's that given, right? So we would like to find the probability that they have a cat given that they do not have a dog, given not dog. So that's going to be the both over the not dogs. So that means instead of looking at the grand total, we're only going to look at the not dog owners. So again, let's first create our total column, total row, add down 5, 15, add left to right, 8, 12, add, grand total of 20. Not going to use that here, conditional probability. So how many do not have a dog? Does not have a dog. That is this row in the table. 12 is your bottom number. And out of those 12, who also own a cat? 2 have a cat. Divide by 2, divide by 2. That is going to be 1/6. And that's the answer here. Should be. There we go. Okay, let's do a little bit harder. Conditional probability, level 2, come at you. Okay, whoa, my goodness, what a big table. The following table represents the highest educational attainment of all adult residents in a certain town. If a resident who is aged 30 to 39 is chosen at random, what is the probability that they have completed a bachelor's or a master's? Round your answer to the nearest thousandth. So we see this word who. Who means given. So given that they are 30 to 39, what's the probability that they've done a bachelor's or a master's? So we want to find the probability that they have done a bachelor's or a master's given that they are 30 to 39. So that means we are only looking at the 30 to 39-year-olds, and within them, we're seeing who has a bachelor's or who has a master's. So let's go ahead and look at only this column, the 30 to 39-year-olds. We are never going to look at the grand total here. So the bottom number here is going to be 3,878. And of these 30 to 39-year-olds, how many have completed a bachelor's or a master's? Bachelor's or a master's. Add those together. 1,269 plus 320. Dinky calculator time. 1,269 plus 320 is 1,269 plus 320. Sorry, one second. 1,269 plus 320 is 1,589. Divided by 3,878 equals, and now here's what I get. So 0.409747. Okay, tenths, hundredths, the 9 is in the thousandths. Now we look at the 7. The 7 is going to round the 9 up to a 10. So this is tricky. So this 09 becomes 10. So your answer is 0.410. You need the 0 at the end in Delta Math. Don't forget it. 0.410. And there we go. Cool. All right. So, oh, I got one more. What am I saying? All right, for one more. Okay, so here's the problem we're going to look at. It says given the probability of A is 0.56, the probability of B is 0.45, and the probability of B given A is 0.7, find the probability of A and B, round to the nearest thousandth if necessary. So in this problem here, we're going to use the conditional probability formula. Now, the only conditional probability they give you is this one right here. So we are going to do the probability of B given A. Well, that is going to be the probability of A and B, the both, over the probability of A, the given. So I'm given the conditional probability. It goes right there, 0.7. I'm looking for the and probability, so I'll put an X on top. And I'm given the probability of A is 0.56. So notice that this probability of B, that's extra information that I do not need. And now I have to solve this for X. Since the X is on top, we're going to multiply by the denominator of 0.56. When you multiply by 0.56, the 0.56 cancel, X comes out by itself, and now you just do 0.56 times 0.7. And that is 0.392. 0.392. 0.392. Oh, submit. Cross your fingers. Yes, got it right. So this one, you have to make sure you use the formula. And again, identify what conditional probability they give you and go from there. Good. So this is conditional probability. The geometry class really focuses on conditional probability. So make sure you're really doing this section well. All right. If you have questions, go ahead and ask.